So let's start at the beginning. What is data? We're going to ask a lot of questions and maybe even find some answers. We're going to look at types of data, variables, and then ask some questions about how we gather data and how we visualize data. So let's start. Really basic. What is data? Take a minute. Go figure it out. Google, what is data? Come back when you have a single word that you think is the best synonym for data. You probably came up with the word information, and that's a really good synonym. Data is giving us information about the world. So how do we get data? We're measuring it, we're gathering it, we're collecting it. It's out there in the world, and we are measuring it. And then what do we do with it? Raw data is not information by itself. We need to transform that data in order to create usable information. So we organize it, we analyze it, we summarize it. How do we report data? This class we're going to talk about reporting data both in words as a narrative and also in charts, figures or graphs, and tables. So let's go back to the types of data. We can split data into two big categories. We can split data into qualitative or quantitative. Qualitative data are written descriptions. They're really rich details. They are very hard to summarize. There may be the things that you'd find in an anthropology class where someone has taken field notes and has described everything that they see. It's giving all the details, but very hard to make comparisons, very hard to summarize. And that's often a good first step when you're investigating a new topic. What we're going to focus on in this class is quantitative data. So the next step is to go back and gather more quantifiable data, numbers, standard categories, limited choices, way easier to summarize. You can look at your quantitative data and make judgments about which has more, which has less, whether they're equal, because they're numbers. They have an inherent ability to summarize and compare. So this class we're going to be looking at quantitative data. Raw quantitative data are the actual measurements. They're the observations. So in this example, each row is one participant. Each column is one variable. So for example, variable 1 is all in column B. The scores on variable 2 are all in column C. And we can see that participant number 2 had level A of variable 1, and then scored a 2.1 on variable 2, and a 115 on variable 3. So the raw data, each row is that individual participant, each column is a variable, and it's really hard to see the pattern. It's really hard to get the information out of that. We're going to need to summarize and transform that data. All right, I've been talking about variables. Let's make sure that we're all on the same page. A variable is any characteristic or quality that varies. It's something we measure or manipulate. They have to vary. If there's only one level, it's a constant. So if you take a look at this crowd of people, you can see that these people have a lot of visible variables where they differ, maybe by gender or age or ethnicity. And then there are less visible variables. Maybe their personalities are different. Maybe their IQs are different. There are maybe some factual differences that might vary in this crowd, educational achievement or income. We could think of a lot of different variables in that crowd. When we measure variables, we're either measuring them categorically or continuously. If they're measured in categories, the levels vary in quality or kind. The levels are discrete and they're mutually exclusive. You can't be a little bit of each. You're either one group or the other group if the measure is in categories. If the variables are measured continuously, their values, they vary along a continuum. They vary in quantity or amount. So you're asking how much of something someone has. So categorical variables have levels. Continuous variables have values or scales. So let's practice that a little bit. Categorical variables, they have levels, quality or kind. Those levels are discrete. Those levels are mutually exclusive. And the levels are their group labels, they're words. So a variable state of residency, you can imagine the levels. I'm a resident of California, I'm a resident of Oregon, I'm a resident of Virginia. Those are labels. Those groups are labeled in words, and they vary in quality or kind. Variables that have been measured continuously vary in quantity or amount. They're numbers along a scale. They're along a continuum. They could theoretically take on any value, or they could be discrete values. We're going to lump both of those together as continuous variables. So something truly continuous, I could ask you, how long have you lived at your current address? So your residency duration, and I'm going to measure that in years, months, days, hours, seconds. I'm going to measure it truly continuously. Another example of something that we're going to consider a continuous variable, because it does vary along a scale or continuum, though it is a discrete value, would be maybe your family size. So I could ask, how many siblings do you have? How many siblings were in your family? You're going to answer with a whole number, 1, 2, 3, 4, 5. You can't answer with 2.7, but they're still continuous. It's still along a scale, even though it's not truly continuous, even though they're discrete values. If you've measured a variable continuously, you can always convert it to categories. So if we measure a variable of reported pain on a scale from 1 to 10, we can then lump those together and look at the low, moderate, and extreme pain categories. So we can take a continuous variable and lump it into a categorical variable. You can't do it the other way around. You can't go backwards from categorical to continuous. All right, let's put those variables into motion. Data is giving us information about relationships between variables. And it's these relationships, we're looking at one variable as the predictor variable and the other as the outcome. Sometimes they just co-occur, they're just occurring together without being directly associated. But usually if we're looking for useful information, we're looking for what variable predicts what outcome. And so data is going to allow us to answer questions like, as income increases, does happiness also increase? Can you hear the labels of those two variables? There's a predictor variable. There's an outcome variable. Now, if income was being defined in dollars, like salary, would that be continuous or categorical? If we said happiness was on a scale from 1 to 100, is that going to be continuous or categorical? So if we define both of our variables continuously, as income increases, does happiness also increase? If that's the question we're asking, we might end up with a visualization like this. If our variables were defined categorically, we might ask, does your educational achievement influence your income? And so we might simplify that question to, do college grads make more money than non-grads? We're looking for those relationships. Sometimes this relationship is describing a causal relationship. Sometimes it's describing just an associative relationship. To conclude causation, the researchers must have started with equal groups, and they must be in control of the predictor variable. They must have manipulated that predictor variable. Otherwise, they're just describing an associative relationship. So where have we got to so far? I've given you a lot of pairs of words. I said that data could be qualitative or quantitative. And within that, I said, this class is really going to focus on quantitative data. Within that quantitative data, I said that variables could be measured categorically or continuously. And we're going to be using both categorical and continuous measurements and looking at those, how those drive the choices in visualization. We've said that in a relationship, one variable is usually the predictor and the other is usually the outcome. And then we said that the relationship between those variables, it could be a causal if we've manipulated the predictor. Otherwise, it's an associative relationship. So why do we gather data? We're gathering data to try to understand the world. We're generally going to be testing our ideas. We're going to be informing our theories. We've all got theories about how the world works. Some of the theories that you have are quite rudimentary. They're not based on much actual information about the world. Other theories that you've got are really well informed. They're very well supported. You've had a lot of experience, and you've got a very well fleshed out theory. These theories help us explain the relationships between variables. So not all theories are equal. Within each of us, you've got some areas that you know a lot about, where your theories are sophisticated and are probably really accurate. And you've got other areas where you don't know very much about, where our theories are really barely more than opinions, and opinions aren't theories. So we need to recognize that all of our theories about the world are tentative. They need to be able to change. You need to be able to look at the world and change your mind and adapt your theory. You need to adapt your theories to new data. We're constantly gathering data with the hopes that this will improve our theories. I bet your theories are changing rapidly with the amount of information you're being presented with at university. So we gather data to inform our theories, and then those theories let us make predictions about what's going to happen next. So we're understanding the world in order to make predictions and in order to inform future decisions. Why do we visualize data? So charts or graphs or figures and tables are designed to give us an immediate visual representation of data. We're visual creatures. We're going to be learning how to really clearly communicate information visually so that the reader can easily apply their visual reasoning to understand the story that this data is telling. The visualization is going to show the pattern of the data. It's going to show the relationship between the variables. And ideally, you want it to tell a compelling story. The creator, you, the author of these charts, is going to need to make a number of decisions and is going to work to organize and summarize that data, and is going to do the work so that the viewer doesn't have to, so that the viewer can easily see the story that the data is telling. There are decisions all along the path, from gathering the data to organizing it, to summarizing it and displaying it. And in many cases, there's not a single correct decision. There's a bit of a science, but there's a bit of an art here. And it's up to the researcher to choose between good alternatives. So we're going to be focusing on what those decisions are, how we know what the options are, how we decide between those options, and really discovering the consequences of the different decisions as we move through visualizing data in the social sciences.